to rearrange formula, we first have to understand what are the basic operations. So that's just simply us thinking of our pluses, subtractions or minus. We have division, multiplication. You will come across the root. You will come across powers or indices or exponent, whichever you want to call it. Now, once we can see what our operations are, our basic operations, we now need to consider what the inverse operations look like. And all that is if I'm adding something, so say I am adding 9, which of the other operations we have here is inversely proportional or inverse to adding? And I'm pretty sure for this one, you'll tell me that it's going to be subtraction. So for addition, its inverse will be subtraction. And of course, for subtraction, its inverse will be addition. For division, its inverse will be multiplication. And for the root, its inverse will be the powers. So what that means is to undo a root, we will use its equivalent power. To undo some form of division, we will divide by that same, we will multiply by that same quantity, or vice versa. To undo some form of multiplication, we will divide by that same quantity. So if we have times by 7, to undo that, we divide by 7. So let's get into rearranging formula, and this will be very detailed. After this lesson, you should have little to no issues with the topic. So let's start with a simple formula such as force equals mass multiplied by acceleration. And in this example, we're going to make mass the subject. Now, the first thing that we need to sort of be aware of is whenever we have two letters next to each other as it is now, the operation that we're looking at between them is really multiplication. So with that, if we're going to make mass the subject and the operation that we have between mass and acceleration is multiplication, then we know the inverse of multiplication to be division. So if we were to divide by acceleration, like that, then right here, acceleration will cancel out acceleration, leaving us with just mass as force over acceleration, like that. And that's us making mass the subject of the formula. And you will see this variation quite often. It's the same thing that you use with speed, distance, time, and so forth. So you will see it, for example, in this one, stress, that symbol is sigma for stress, equals force over acceleration. It's the same sort of system we're going to use. So let's take a look at this one next. So in this example, we're going to first make force the subject of the formula. And then in the second context, we're going to make area the subject of the formula. So let's start off with making force the subject of the formula. So again, on the right hand side, we have here force divided by area. And what we need to do, we need to isolate the F, which represents force. So we need to do the inverse operation of everything that surrounds the F. And in this case, it's only the A, which is area, that we're dividing by. So as you can imagine, if we were to multiply by area, then that would cancel out the area that we have there. And we're doing the same thing to both sides. So inevitably, what we have is stress multiplied by area equals force. And that's us rearranging to make force the subject. Let's now make area the subject of the formula. So for this one, it's slightly different. There are quite a few different ways that we can analyze this. We obviously have area in the denominator, And what we need to ensure that we do is having area in the numerator. So that's the first thing to consider. Of course, we have force there as well, but that's the part that will become quite apparent once we get area in the numerator. Now, there are a few options, as I've said before. So let's look at option number 1. Option 1 is we can just see this as stress over 1. So what that does is it allows everything to look like a sort of like a fraction then. And what we do with this fraction that we create is we're going to do, I hate to say it because it's not conceptually solid, but we're going to do a cross multiplication. So we're going to multiply f times 1 to give us f. And then we're going to cross multiply here stress multiplied by area, which gives us stress times area. And now what happens is this looks exactly like what we had before. So we're just multiplying now area by stress. So the inverse of this operation is to divide by stress. So we end up with A equals F over stress. So the other variation of this, or the more fundamentally solid method here, is because what we need is area in the numerator. What we could do here is first multiply both sides by area. So when we do area multiplied by area like that, when we do the right hand side multiplied by area and then the left hand side multiplied by area as well, well, area will cancel area. So what we're left with is just A times stress equals F. And this now looks identical to what we had previously. So because we are multiplying our area by stress, the inverse is to divide our force and area by stress. And that's it. So those are the two methods that you can use for that one. So let's look at two more variations before we move on to level 2. So for this one, I'll use final temperature is equal to initial temperature plus change in temperature. And we're just going to make initial temperature the subject, or we could make change in temperature the subject. But let's just use that one, initial temperature. So what's happening here is we're adding change in temperature to initial temperature. So if we were to just do the inverse of adding, so we would be taking away change in temperature from either side, that would effectively cancel out that one there. So we're just left with final minus change in temperature. That would be equal to initial temperature. And if we were to go about business the other way, where we wanted to make change in temperature the subject, then because everything here is being added, it's just to subtract as the inverse, and that would be it. Final example at level 1, say we have change in velocity to be equal to final velocity minus our initial velocity. And what we want to make the subject here is, let's say, final velocity. Then if we're making this here the subject, final velocity, because we're subtracting initial velocity, then the inverse again is just to add initial velocity. And that's what we're left with. So if you were to show working by doing it to either side like that, then that's fine as well, as long as you understand the principle. Now this one can have a little twist to it, because let's venture this one into some level 2 territory now. So let's say what you needed to make the subject was the initial velocity right there, the u. Then there are actually two things that you need to do here, and there are more than one ways to do it. I'll show you first method. So if you're making initial velocity the subject, then this final velocity, that's what's positive. So the inverse of that is to subtract actually. And what you have is change in velocity minus final velocity, but that will be equal to negative u, or negative initial velocity. So what you do here is you would divide through by -1, and effectively you'd be reversing these symbols. So what you would have is negative, change in v, and then plus v, that would be equal to u. So you'd effectively reverse the symbols. So to make it look more pleasant, you can just simply write u equals v and minus change in velocity, just shuffling around the same thing. These are the same things right there. So all of that was level 1. Let's get into some more juicy stuff at level 2. So this level is where we will have multiple basic operations. So let's say we use our SUVAT formula. So V equals U plus AT. Now, remember when I said earlier that difficulty doesn't look like how long the formula is or anything like that. It just depends on how buried or how many operations surrounds what we want to make the subject. So here, depending on what we want to make the subject, this can either be a one-step operation or a two-step operation. If we just wanted to make U the subject, then it would just be us subtracting V. Would just have V minus AT, and that would be equal to U. But let's say we want to make acceleration the subject. Now you have to look at everything that is happening, all the operations that surrounds the acceleration, which is A. And you have that plus U, and you have that times T. So you have plus U and times T. So then you will have to do the inverse of those two. And the order in which you do them, it does matter as well. So it's kind of like the reverse order of BIDMAS. So like here now, you would first need to subtract the U. So you would end up with V minus U equals AT. So that's when we subtract U from both sides. That's what we have. And then this is where you can now do the inverse of multiplying by time, which is to divide. So this would give us V minus U all divided by T equals A. So if we're dividing some quantities, like in this case, it's everything that's on the other side that you're dividing. So it has to be all divided by T. So let's use this centripetal force formula. So F is equal to mv squared over r. Now, once again, depending on what we want to make the subject of the formula, this can look quite busy or it can look fairly straightforward. So if we were to make, let's say, either m or r the subject, then it could be fairly straightforward with just one step or two steps at best. But if we're going to make, I'm pretty sure you're looking at this and shouting on your screen saying v squared or v. So let's make v the subject for this one. And again, we need to look at the variables that surrounds the v, and we need to do the inverse of them. So we have times by m and we have divide by r. So right away, you should see where that will be your inverse operation. So when we multiply by r, we would get this f times r. And then when we divide now, which is the inverse of multiplying by our m, that's just fr over m. And that would be equal to v squared. Now the v squared, and we just need to have v by itself. So if you can recall, the inverse of the square is the square root. So what we would do is to take the square root now of all of this. So we'd have fr over m, square root of fr over m. And that's what v would be equal to. We could look at a lot more variations and different formulas that would give us various challenges, but the video may go on and on and on. So let's just skip to level 3 now. What I would say, okay, this here is some level 3 rearranging stuff. And I'm going to use this natural frequency formula where we have f equals 1 over 2 pi, and times by the square root of k over m. Once again, depending on what we want to make the subject, this can look quite busy or it can look quite straightforward. So for this one, I'm just going to use k as the subject, and we could use m afterwards, but let's just start with k as the subject. So we have to first look at everything that's happening around the k, and we're going to do the inverse of that. So right here we have this dot which represents multiplying. So we're multiplying here by 1 over 2 pi. So the inverse of that will be 2 pi over 1. Or we in other words, multiply by 2 pi and divide by 1. Then we have this square root. So the inverse of that will be to do the square of. Then we have divided by m. So let's do that in the same order. So our step 1 here would be to get rid of the 2 pi, the 1 over 2 pi. So what we would have is f times by our 2 pi. So that's the inverse of over 2 pi there. And that would be divided by 1. Now, because it's divided by 1, we don't need to include that. So that's f over 2 pi, and that's now equal to square root of k over m. Now, at this stage, we need to get rid of the root, square root. So the inverse of that, of course, is the square. So when we do that, square both sides, we would have to put this here in bracket. So that's one common mistake. And what we're squaring now is everything that's contained in the bracket. And so what we have left is just k over m. And at this stage, everything that we have done so far, it's really the same steps that we would take to find either k or m. The difference is quite subtle. So I'll just take one variation where we're making k the subject. And because we're dividing by m, that's straightforward. So k would just simply be equal to m multiplied by all of this. So f times 2 pi and square that. So that's what k would be equal to. And let's say we wanted to make m the subject. Well, m would just be, if we were to do the same thing as we did before, where we multiply both sides by m, then we would have m cancelling m over on this side. Okay, like that. So what we would be left with then is just to divide our k by what we have there. So then for m, we would have k over all of this, or f times 2 pi and square. You can even look at the formula up top and see exactly that. That's what we have there to do to get the m as the subject. So that's quite nice to see as well. We could look at several more variations with varying difficulty levels, but again, the video will go on and on and on. So what I would like you to do, if you would like me to do more challenging, or if you would like to send me some questions to look at, then that would be even more fantastic. So just leave a comment, let me know where to go next with this, if it's worth being a playlist or a series, and I'll tackle that for you. So until next time, I will see you in the next video.